All right, welcome. Today we're talking about some pretty exciting stuff. Box and whisker plots. So we've got boxes and whiskers coming off when we are plotting this. Ready for a good time here. Okay, so first let's start with five numbers summary and interquartile range. The following are the ages of 13 music teachers in a school district. Okay, so we can see they're already ordered least to greatest. The youngest is 32, the oldest is 54. So if you look over here on the side, we can say the minimum age, 32. No one straight out of college. The oldest is 54. All right. Give the five number summary in the interquartile range for the data set. So we're going to start with the minimum. We said that was 32. I'm sorry, so the smallest number. And then our maximum is the biggest number or greatest number. Okay, so now we're going to find the median. Divides the data in half. So halfway through it, we know we can count and work our way to the center. This set of data only has one middle number, which is 41. Sometimes you'll have two, and you have to find the average of those two. So now we're going to find the lower quartile, so we'll find the median of the lower half. So we divide it in half, now we're going to divide the halves in half. So we crossed off 41, that's no longer a thing, so now I need to just look at these six numbers over here. So since it's an even number, the number between 36 and 36 is just 36. Then the upper quartile, the median of the upper half, and there should be 6 over here, so between 45 and 47 would be 46. Okay, so now I find the five numbers summary. We have the minimum, we have the median, we have the maximum, lower quartile, upper quartile. Okay, so now for the interquartile range. Well, let's look at what that means. We know what the range is. That's maximum minus minimum. So interquartile, so we're looking at the difference between the quarters, between the upper and lower quartiles. So the difference between 46 and 36. So my interquartile range is 10. 46 minus 36. All right, so let's take this to the next step. Let's construct a box and whisker plot. What we need to do is find those five numbers. We don't need to find the interquartile range, but we do need to find those five numbers. Here are the scores of 16 students on a history test. Okay, so the highest score was a 91%, lowest score was a 57%. So over here we can write that in as our maximum and our minimum. Now we need to find the median. Now notice it's an even number, so it'll be between two numbers. So as I work my way to the middle, we have two middle numbers, 75 and 76. So the median is halfway between that, 75 and a half. Okay, so now when I'm going to break it in half, 75 is going to go with the lower half and 76 will go with the upper half. So we should have 8 numbers in each. So my lower quartile, looking to the left here, is between 63 and 63. 63. My upper quartile is again between 85 and 85, so it's just 85. Okay, we don't have to find the interquartile range yet. So now we can use a we're going to use a box to show the lower quartile, median, and upper quartile, and we're going to use whiskers to show the minimum and maximum. All right, so let me show you what I mean. I'm going to go ahead and mark all my points on the line graph here, or line plot here. So we have it right on 57, uppers at 91. I could just go ahead and put a line on all these. It'd probably be the easiest thing to do. 75.5 has to go between 75 and 76. Okay, so from lower quartile to upper quartile, I'm going to make my box. So there's my box with the median cut in it. And then we have my whiskers coming off the edge here. So that's a box and whisker plot. All right, let's do that again. We're going to use a box and whisker plot to compare our data now. All right, so you can see below, 2 athletes are training for a cycling race. Each athlete recorded the distance in miles of their previous 60 training rides. Wow, that's a lot of training rides. The box and whisker plots shows below summarize the distances recorded for each athlete. Use the box and whisker plots to answer the questions. Okay, so let's first look at athlete A. His shortest was 15, his longest was 38 here. Okay, and you can see his median, he typically rode about 32 miles. All right, athlete B here, his shortest was 19 miles, his longest was 31 miles. So you can see his shortest was actually longer than athlete A's. His longest, though, was shorter than athlete A's. So who was better at training? Who trained better? I would say athlete A was the better trainer and trained at least in terms of how many miles they trained. Okay, let's look at our questions down here. Which athlete had distances with a larger interquartile range? Remember how we find the interquartile range? We look at the size of the box. So I'm going to do this in blue so you can see a little better. Athlete's A was from here to here. Athlete B's was from here to here. So you can see athlete A's box is bigger than athlete B's. So athlete A had the larger interquartile range. Not because it went higher, but because the box is bigger. The range is greater. Okay, which athlete had a smaller range of distances? Okay, so now we're just looking at the range, not the interquartile range, but the range. So we're looking at maximum minus the minimum. So if we look at the difference between those lines, clearly athlete B's here is a smaller range than athlete A's. Okay, next question. Which athlete had a greater median distance? All we have to do for median is to look at the middle of where our box is. So who had a greater median, which was farther right on my number line? Clearly athlete A's. Okay, then which athlete went on the shortest training ride? So what would tell us the shortest? Whatever the minimum number is on there. Okay, so the minimum number for athlete A was 15, minimum for athlete B was 19. So athlete A had the shortest training ride. Single training ride. Okay, that's box and whisker plots. Watch this as many times as needed to understand this.